Now we will define heat. Heat is the form of energy flowing from one body of matter to another spontaneously due to their temperature difference. Now talking about the characteristic of heat, we can say heat always transfer from body of higher temperature to body of lower temperature, or in other words, heat flow is spontaneously means by its own, from a hotter body to a colder body. So let us discuss about hot and cold objects. So in our daily life, we come across many of the number of objects. Some of them are hot and some of them are cold. Now we say heat is hot, tea is hot, ice is cold. Some objects are hotter than others and some are colder than others. Now how we often decide object is hotter? By touching the object. We cannot always rely on our senses of touch to decide whether the object is hot or whether the object is cold. So hotness of the object is measured by its temperature. And when we add heat to body, motion of the particle inside the object increase. And when we remove the heat from the object or body, motion of the particle inside it decreases. So now we will define temperature. Temperature is the measure of degree of hotness or coldness of the object. Temperature of something tells us about hot or cold something is. Now let us see what are the effects of heat. So when we provide heat to an object, there are certain changes taking place, that is known as physical and chemical change. First we will talk about physical changes due to heat. Now change in temperature. So on adding heat to any body, the temperature increases, and on removal of heat from any body, its temperature decreases. So there is change in temperature. Second is change in state of the object. When we provide heat to the body, there is this change in the state of the body. Example, when we provide heat to the ice, it melts to form the water. Now the third change is thermal expansion. Solids expands on heating. This phenomena of expansion of matter is known as thermal expansion. And another change is the chemical changes. On heating any reactant, many chemical changes takes place and it forms the product. Now, measurement of temperature. How we record the temperature? So temperature is measured by a device called thermometer. Now temperature is measured in degrees. Temperature is measured in two scales, degree and Fahrenheit. Now degree centigrade, degree and C is the symbol for the Celsius scale, and degree and F is the symbol for the Fahrenheit scale. In the Fahrenheit scale, it is most popular in the United States, and Celsius is most popular in the Canada. So normal temperature of Fahrenheit is 37, and in normal degree centigrade is 37 degree, and normal Fahrenheit is the 98.6 Fahrenheit. Now we can define thermometer is an instrument that is used to measure temperature. Now measurement of temperature on different scale. First is degree centigrade. On Celsius scale, freezing point of water is 0 degree and boiling point is 100 degree centigrade. This temperature measurement is calibrated, or thermometer is calibrated from 0 degree to 100 degree. On Fahrenheit scale likewise, 32 is the freezing temperature Fahrenheit and 212 Fahrenheit is the boiling temperature. So it is calibrated from 32 to 212 degree Fahrenheit. Now one formula to remember: conversion of centigrade scale to Fahrenheit scale. Degree Fahrenheit is equal to degree Fahrenheit into 9 upon 5 plus 32. So we can, in short, we can say 9 upon 5 C plus 32, and conversion of Fahrenheit to centigrade is the degree centigrade equal to F minus 32 into 5 upon 9. Conversion of Celsius scale into Kelvin scale, Degree Kelvin is equal to degree centigrade plus 273.15 degree. Now let us talk about the types of thermometer. First is clinical thermometer. The thermometer that measures the temperature of our body is known as clinical thermometer. You might have seen at your home. So clinical thermometer. From the picture, it is very clear what is the construction of clinical thermometer. A clinical thermometer has a long, narrow glass tube. It has bulb at one end containing mercury. It has a scale called Celsius scale marked in degree centigrade. A clinical thermometer reads temperature from 35 degrees centigrade to 42 degrees centigrade. And also clinical thermometer has a small kink or constriction, you can say, near the bulb or the tip of the thermometer to prevent the mercury level from falling down when it is heated. So the normal temperature of human body is 37 degrees centigrade. So let us learn about reading a clinical thermometer you might have done at your place. Now wash the thermometer with an antiseptic solution, hold it firmly and give it a few jerks to bring the level of mercury below 35 degrees centigrade. Then place the bulb of the thermometer under your tongue. After 1 minute, take out the thermometer and note the reading. This will be your body temperature. Now this is the age of digital thermometer. You might have seen this also. Digital or electronic thermometer are preferred over the conventional mercuric thermometer as we have seen earlier. In digital thermometer, they are easily read because of LCD display of the temperature of the person. They are also mercury free. Then the last is the laboratory thermometer. These are relatively longer. A laboratory thermometer has long narrow glass tube. It has a bulb at one end as a normal thermometer. It is scale marked in degree centigrade. The range of the thermometer generally is from -10 to 110 degrees centigrade. So how to measure the temperature with this big laboratory thermometer? Take some tap water in a beaker. Dip the thermometer in the water so that the bulb of the thermometer does not touch the bottom or the side of the beaker. Hold the thermometer vertically. The mercury level rises. Wait till the level of mercury becomes steady. Note the level of mercury. This will be the temperature of the water. Transfer of heat. Transfer of heat takes place from the body at a higher temperature to the body at the lower temperature, and this is known as transfer of heat. By three methods heat can be transferred. First is conduction, second convection, third radiation. Now first is conduction. So go through the pic also very nicely. Now, conduction is the process by which heat is transferred in solids from hotter end to the colder end. So, to look for the process, let us see the activity. Take an iron or aluminium rod or a strip. Fix a few wax pieces, one at the equal distance. Okay. Now, clamp the rod to a stand. Heat the other end of the rod. The wax pieces begin to melt and fall down from the heated end. This shows heat is transferred from the hotter end to the colder end by conduction. Now, process of conduction, transfer of heat is through the direct contact. Second, you can say occurs any time objects at different temperatures are touching each other. As long as the objects are in contact, transfer of heat will continue until the temperature of the two objects is the same. For example, very interesting, you can see when you leave a metal spoon in a pan of soup that you are heating on the stove, it may burn your finger. The spoon, why a spoon will burn your finger? Because spoon is in direct contact with the hot soup and heat is regularly transmitted from the pan to the spoon. So let us talk about conductors and insulators. What are conductors? Conductors are materials which allow heat to pass through them easily. Example, iron, aluminium, copper, etc. Or you can say most all the elements or metals. Insulators are the material which do not allow heat to pass through them easily. Example, wood, plastic, glass, rubber, air, water, etc. The next type of heat transfer is known as convection. Now, in the convection is the process by which is transferred in liquid and gases from the hotter part to the colder part. One activity we can do, we can take a round bottom flask, we can keep it on the tripod stand, put a crystal of potassium permanganate in it, heat it in the burner. The water at the bottom become hot and rises up, and the cold water from the top moves down. This water also becomes hot and rises up, and cold water from the top moves down, and process continue till all the water get heated. This shows that heat is transferred by the convection process. So about convection we can say the transfer of energy taking place in liquid or gas. When a part of gas or liquid is heated, the particle is made up or move faster and spread out more. The moving particle bump into another particles and causing them to move faster and spread out more. Another example of convection in air you all might have felt is the air near the heat source get heated and rise up. The air from the sides move in and to take its place. In this way, the air gets heated. If you keep one hand over a flame and one hand on the other side of the flame, the hand at the top of the flame feels hot because the air above it is heated by convection, and hand at the other side do not feel as hot because there is no convection. Another example of convection is the sea breeze and land breeze. Now in sea breeze, during the daytime, the land gets heated faster than the sea. Do you agree, all of you? So the air above the land gets heated, become hotter and rises up. And cool air from the sea moves towards the land. This is known as sea bridge. During night, what happened? The sea cools down slowly than the land. And so the hot air above the sea rises up and cool air from the land moves towards the sea. And this is known as land bridge. So you can see from the pictorial diagram that is during the daytime from the sea cold bridges are coming towards land. So they are known as sea bridge. And during night land air from the land enters towards the sea. They are known as land bridge. In more detail, you can see air moves from the sea during the daytime. And land bridge, air moves from land at the night time. Third type of process of heat transfer is known as radiation. Now, radiation is the process by which heat is transferred from one place to another without help of any medium. No medium is required. Example, heat from the sun reaches the earth by radiation. When we sit near a fire, we feel warm due to heat radiated by fire. Although we are not touching the fire, but we still feel the warmth of the heat. Now, all hot bodies radiate heat. Now, heat from the sun. We all can feel the warmness on our skin on a sunny day. This is because the energy causes the particle in your skin to move faster and it produces or we can feel more heat energy. Now we can do one interesting activity, dark color surfaces and colored surfaces. Now, dark color surfaces absorb more heat than light colored substances. You all have heard this, that dark colors are good absorber of heat. So take two cans of the same size, paint it one with black and other with white on outer surface. Pour equal amount of water in each and leave them in the sunlight for about 1 hour. Now measure the temperature of water in both the cans. You will observe water in black cans is warmer than the water in the white can. Another we can say that dark surface radiates more energy than the light colored surface. Again, we take the two cans of the same size, one coloring black from out, another coloring white. Now pour equal amount of hot water of the same temperature, say 60 degrees centigrade. Leave them in the room or shed for 10 to 15 minutes. Now measure the temperature of water in both the cans. The water in the black can is cooler than the water in the white can. So we can say black colors are good absorber, or dark colors are good absorber, and dark colors are good radiators also. That's why we wear the light colored clothes in summer and winter, as dark color surface absorb more heat and light. Just now we have seen. So dark color surface radiate more in heat than the light color surface. So we wear dark colored clothes in winter because it absorb more heat and keep us warm. And we wear light colored clothes in summer because it reflects most of the heat and keep us cool. Now we wear woolen clothes in winter because wool is a poor conductor of heat, and the air between the wool fiber prevents the loss of heat from our body, so we feel warm. It is clear picture of conduction, convection and radiation process. Now we will talk about wind. Wind is the horizontal movement of air from an area of high pressure to area of lower pressure. Why this happens? Why air moves? As there is uneven heating of the earth that results in global wind pattern. Now there are two types of winds, local winds and global winds. Local winds are winds that blow over very short distance, and global winds are the wind that blow steadily from specific direction over long distances. So there are two reasons why wind occurs. Now wind is caused by difference in the temperature and difference in the pressure. Now difference in temperature leads to wind as warm air rises. Warming air makes the molecule move faster and spread out. This makes the air less dense, and less dense air is light and will rise. Now cold air. Cold air will sink. Cooling air makes the molecule move slower and group together. This makes the air more dense. More dense air will sink. Now talking about differences in the pressure, rising air creates low pressure. If the air is lifted up, that means there is less air pushing down on the earth. Another case is sinking air creates high pressure. If the air is sinking, moving down, then the air is pushing down on the surface of earth with high amount of pressure.